Hello, watch this video and you will never do any mistake while drawing the equivalent circuit of a solar PV cell. Now, the first confusion that people have whether it should be a voltage source or a current source. This confusion is mainly because the term is photovoltaics and sometimes we call it solar cell or PV cell. Cell is a battery or a voltage source developed by the great scientist Alexandro Volta. So many people consider it as a voltage source, but that is wrong. To know whether it is a voltage source or a current source, we have to look at the characteristic, that is the IV or current voltage characteristic. If it happens that for a source, for any load current, for any operating point, the voltage remains almost constant, it is a voltage source, and for every operating voltage or every condition, if the current remains constant, that is we call current source. Now, if you look at the IV characteristic of a PV cell, we find that for a larger duration of time or for the larger operating point, it is behaving like a constant current source. That is why a PV cell or a PV module is modeled as a current source. So the first confusion is now clear that it is not a voltage source, it is a current source. And then the confusion arises whether we should consider the diode in parallel with it, whether it should be parallel, that is the cathode should be in the direction of the current or in the opposite direction of current, whether it should be the anti-parallel. Now in most of the circuits, in power electronic circuits, the diode is used as a blocking device, but here the diode is used to model the nonlinear part of the characteristic. As you can see in the three curves, the red curve shows us an ideal current source where it is constant for every operating voltage. And the second part shows us a diode where the diode current. Now, if you take minus of that, that is ideal current source minus the diode current, then we get a curve that is somewhat similar to the curve that we have taken here in the IV cell. So, the current should be negative, and to have negative, we should have anti-parallel diode. So that should be the arrangement. So the second confusion of ours is solved. And the third confusion that may happen after that we are using two resistances. One is series resistance and parallel resistance. Now many people get confused whether we should have the series resistance first or the parallel resistance first. Now to answer this question, we need to know what is series and why it is something is parallel. The parallel resistance or shunt resistance is used to model the leakage current, because all of the current that is going through, that is generated through the photocurrent, it is not available at the end. Some leakage is there through the solar panel itself. So it is an internal property. That is why we use this RP, that is R shunt or shunt resistance. And the series resistance is merely for the voltage drop that happens at the contact. So it is outside the PV cell. Therefore, first we have to consider the effect of leakage current, and then we have to consider the effect of voltage drop. So first we have to do the parallel current and then we have to do the series voltage drop effect. So this is our right circuit. First we have to consider the parallel resistance and then we have to consider the series resistance. Also, when you are doing this in any interview or examination, make sure that you show the polarity, that is the positive terminal and negative terminal. Okay, if you do these things, that is everything will be all right. Thank you for watching.